Good evening, everyone. Hey, can you hear me okay in the back? Okay, even over the AC? Okay, good. All right, welcome to the Austin Deep Learning Meetup. My name is John Ramey. I'm one of the organizers of the meetup. If you haven't been here before, the meetup has been around for a little over 2 years now. Might be doing the math wrong. That's ironic. I lead the data science team at Novi Labs, a startup here in town. It's a pretty sweet gig. We actually do machine learning for fun and for money. If you are a full stack engineer and you're looking for a gig, please hit me up. We are looking for some really talented people, looking for some senior people. I am very excited to finally partner with Kung Fu AI. They are sponsoring our meetup tonight. The pizza in the back, hopefully you got some slices. It is paid for and brought to you by Kung Fu AI. I'm very excited about partnering with them. So before we get going, I'm going to turn this over to one of their representatives. And he's going to tell you a little bit about Kung Fu, and they're looking for some good people too.
Thank you very much. My name is Steven Straus, and I'm one of the co-founders at Kung Fu AI. And we're excited to sponsor this meetup. We are an AI consultancy, so we work with companies to help build out custom solutions, primarily in the areas of NLP and computer vision. We also offer strategy services, helping companies figure out what they could and should be doing in this space. We have some great companies that we're working with, which we're very proud of, including some big names here in Austin. Keller Williams is the world's largest realtor by number of brokers. They're our largest client. We're just starting work with South by Southwest, the company, and we'll be part of their tech stack a year from now. Silicon Labs, which is headquartered downtown, and who doesn't love Alamo Drafthouse? So we have other clients, but those are some great names, especially for the Austin crowd. And if you're a drinker of beer, Karbach out of Houston is a great brand. We've done some interesting work for them. So part of the reason we're sponsoring this is that we are hiring. And so if you're interested, if you're a data scientist, a machine learning engineer, we're actively hiring, and we'd love to hear from you. So thank you very much for having us.
Thank you so much. Again, we are so excited to partner with Kung Fu. So I'm going to move to the next thing here. So we have a meetup already scheduled for April. It's going to be, I'm going to be giving a presentation on TensorFlow.js. I haven't given a presentation here in quite some time now, so I'm going to show you what I've been up to on my own time. And we are looking for some talks for May and June. Have some people who've reached out, haven't really finalized anything. We give priority to those things you've built on your own. So we're not necessarily looking for just like an intro to some technique or some intro to some framework. Show us what you built, and that can be anything from taking something you found on the web and reverse engineering it, tinkering with it. We actually had a guy who a few months ago he didn't like the standard approach to some of the style transfer stuff, and he created his own thing and wrote an archive paper and everything. It was legit. So if you have something in mind, please reach out. You can hit me up on Slack. If you're not in the meetup Slack, there's a lot of conversation in there. I'm very excited about that. Also, hit me up on the meetup site, or just hit me up after. The last thing before we turn it over to Pablo, our speaker for tonight, is we usually go and grab a drink at CU29 right across the street immediately after the meetup. A lot of good conversation. We usually have 10 or 15 people, and talking about everything from deep learning to where is this all playing out? What do things look like in the next 2 to 5 years, both in Austin and throughout everywhere else. We don't care about everywhere else. We care about Austin. All right, I'm going to stop talking. I'm going to turn this over to Pablo Vela. I'm very excited to introduce him. When he reached out to me and said, hey, I really want to give an overview of GCP and Tensorboard, I was like, we haven't actually done that, believe it or not. And we need some people to really kind of give some detail as to how do you ship this stuff? How do you actually implement, or how do you walk through some of the implementation details? So very excited. I'm going to turn it over to you now, Pablo.
How's it going, guys? My name is Pablo. I am a computer vision engineer at a startup here in Austin. We build a virtual office where you can collaborate with different people. It is mainly aimed at software developers. So the idea is basically a lot of people use things like Slack and Skype to try and communicate with each other. And we're trying to make it so that using your VR headset, it is as if you are in the same room as this person, since nothing can kind of replace that in-person communication that you have. One second. So today's talk, I just kind of want to go through and show you guys how you can use GCP and PyTorch and Tensorboard to quickly iterate on any sort of machine learning problems you might have. In this case, I will just be showing you how to do a really basic transfer learning example for image classification, and how that all kind of comes together using Google Cloud Platform and such. Yeah. Oh, did it not work? Yeah. Okay. 1 second, guys. Sorry, little technical problem here. Got it up here. It doesn't seem.
Okay, let me hit OK.
See if you can, Avi, do you want me to just? So it's not the laptop.
I'm going to go talk to the AV person.
Okay, sure. And I'll just continue forward. Sorry about that, guys. If you guys can see, we'll have it over on this side and over on this screen over here. In the meantime. Anyways, so I guess the first thing I wanted to talk about is to show you guys, in case you don't have access to GCP normally, they actually have a free tier that allows you to get $300 worth of credits. If you guys just want to tinker around in there and see what you can do without having to spend any money. The only annoying thing is you have to put your credit card in. I don't think they charge you, but this will allow you to kind of check out GCP and see what you can do with it and use all the different services. We will only be using the compute engine today to run a virtual machine. But yeah, and if at any point I'm talking too quickly or you have any questions or anything like that, just let me know, and I can adjust. So I guess the first thing would be how to actually make a virtual machine using the deep learning VM. So the deep learning VM is really, really useful because it includes a ton of different really popular packages that you can use to, there we go, okay. A ton of different packages that you can use to make any projects you might want, and it makes it super easy. It's all plug and play. So the first thing I did was I just went to Google Cloud, and I clicked on console. You'll have to have an account and all that. But to launch a virtual machine, usually what I'll do is I'll go to this little marketplace tab here. And from here, once I click that, from clicking from this navigation menu, you will get this little marketplace page. And you'll just look up Deep Learning VM. And it'll be this first result you see here, which is basically a compute engine. And one of the important things is that you have to have, if you want to use anything like different GPUs on here, you have to have the quota to be able to access those, and that's something you'll have to request. I can't show it on my account as I already have access to these things. But you need to make sure that you actually have the permissions to access the different resources that they allow. But it's super simple. You just literally click on Launch on Compute Engine, and it'll give you a bunch of options on what you want. Another really nice thing about being able to use a deep learning VM is that it allows you to scale to what you want. So seeing down here, you can choose what kind of GPU you might need. So if you need, you don't need a lot, it's something really basic. You just want to kind of iterate on a project and see what you can do. You can just click the single K80. But if you kind of want to go crazy and you need a lot of horsepower, you can always go as many GPUs as you want. Well, not as many, sorry about that. 8 GPUs maximum, which that's a pretty significant amount of power there. But for now, just to kind of show, I'll just have the single Tesla K80. The zones, normally this used to be an issue because GPUs weren't generally available in all of the zones. So you would have to choose whichever zone actually had those GPUs. Now they are generally available, so you just kind of choose the one that is closest to you. And you can kind of look at their documentation to see that with this little learn more. So I'll just call this example, I guess. And the next little portion here is the framework. So this is what will actually be installed. So this is all installed under a Conda package. And there's a bunch of different options on here. The ones that I'll be using is this PyTorch plus FastAI. And there are a ton of different other options that you can choose from. So they have TensorFlow. I think they have 2.0 on there now too, which is really nice. But for now, I'll just click this PyTorch, and that will have everything installed for you. And the other thing that I'll do is also allow all the drivers to be automatically installed once the virtual machine starts up. And then the few other options are the kind of disk that you want. So if you want to have an SSD versus a normal spinning drive, and different networking options. Generally, I leave these alone. And then how big you want your disk to be. This other option here that allows you to access JupyterLab. So when you actually run the VM, it will automatically set up an instance of JupyterLab for you, so that you have an IAD all ready to go. You don't. It's everything is super plug and play, which is what makes it so nice for fast iterations and experimentations. Because we want to use Tensorboard, we actually don't want to access it through the URL. We're going to have to do some port forwarding. So I'm going to leave this off for now, and then you just hit deploy. And usually this takes like 5 minutes to deploy through the deployment manager. But I already have one set up, so I can show you guys kind of what it looks like. So from here, I'll just go to this deployment manager, which is where you'll be able to easily access your VM and your compute engines. And here's the one that I've already made, and this is the one that's deploying right now, but this is the one that I've already made. So this kind of leads you through the steps to kind of get access to the VM. You're going to want to set up this Cloud SDK. It's relatively easy. It takes a little bit of time, but they have a bunch of documentation here, so you can kind of go through that, and it's relatively simple to set up. The other thing is it allows you to copy files directly from your local to your VM using this really simple command here that you can just copy, and then you'll just point towards the files that you want and where they'll end up on your virtual machine. Generally, I actually don't do that. I'll generally just write a script that will pull the data. In this case, I'm using the 102 flower data set, and I wrote a simple Python script that downloads that and pre-processes it and everything. So I'll just go straight to this little command here. I just click this little copy so that I can access the VM. And then here, I would just paste it. The only modification that you would want to do to here is do another port forwarding. And that would be to your local, sorry, 1 second, yeah. To your local machine's port 6006, because that is what Tensorboard will default to. Oh yeah, sorry about that, guys. This will be different for you guys because this has like my project. So when you copy this, it will be specific to your machine and your project and everything. So this will you don't even have to think about it. The only difference will be when you try and do some more port forwarding. So you see over here how we have a -L 8080, which is the port where Jupyter Lab will be on, and then you do the exact same thing, but except for your port 6006. Can you guys see that okay, or should I make it a little bit bigger? Yeah, let's see if I can. Yeah, so it would be basically this exact same command, except instead of 8080, it's 6006, since that's the default for Tensorboard. And I've already done that over here, just to have it up and running. And you can dig it around in there, but that's not really where anything interesting is happening. It'll automatically populate that for you over here. So you would just go onto your web browser and type in localhost 8080 to access your Jupyter Lab instance, and it'll just pop you straight in there. It might not let me now because I already have one running. Yeah, so it's going to say, please use a different workspace because it's already taken up by here. But that's basically what you would do. And here you have access to the VM and everything that's installed on it. So first thing I guess I could show you guys is all the different packages that are on there. So I'll just do a conda list. So everything is done through Anaconda. And it'll have all the different packages on there, as you can see, pre-installed for you and ready to go. For now, the next portion of this talk would be talking a little bit more about the transfer learning and Tensorboard. So in this case, this package that I use to allow you to integrate between PyTorch and Tensorboard is not pre-installed on here, so you would need to do a pip install. And you can see this is the package that I use. It's called Tensorboard X, and it's really simple. You just do you can either build it from source, or you can use a pip install. Here, this command, and you would just run it here inside of this command line, the pip install TensorBoard X. The other thing that you would also need to do is install TensorFlow itself, because this doesn't include TensorBoard. So you need to install TensorFlow, and because this is the PyTorch package, they don't include TensorFlow. That's a separate framework that you would have to use. So I guess the first thing I'll show you guys is the actual TensorBoard X demo, just so you can see what you can actually do with it and what it allows you to kind of do. So let's see. Let's go into TensorBoard X, cd examples, and then let's run the Python script. So what I'm doing when I'm running this Python script is basically creating the event files that TensorBoard will read to display on for you to see kind of your model or different things that you decide to place on there. So you'll have different scalars or graphs or images or whatever you decide to put on here. So when I run this, it'll basically populate that. So what you'll have to do is also have another launcher to actually run TensorBoard. So when I ran this command, it'll make a directory called runs. So let's see, TensorBoard X, example. And if I show you guys what's under there, can you guys see this, by the way, the commands on here? No, you can't see this at all? Let me see if I can make this a little bigger. That's huge, but is that better? Okay, cool. So if I do an ls, so you'll see over here, you can see this runs directory that was created when I ran demo.py. So what you'll do is you'll just type TensorBoard, and then -- log dir, so that's the directory where all of your event files have been placed, and that would be under runs. And so you're pointing basically TensorBoard where to look. So when you hit that, it'll basically start TensorBoard up, and you should be able to see. So you see here, this little thing happened, which is basically telling you TensorBoard is running. And then from there, you would go to another page and do port localhost 6006, which is why you did that port forwarding, so that you can access the same port that is on your VM on your local machine to actually see what's happening. This might be kind of huge, so you may not be able to see. Let me make this just a tad bit smaller. There we go. So this is just an example of some random data. So this doesn't mean anything. This is just showing you what you could potentially put on there. So here they just have different scalar values on here that they plotted against each other. And it lets you see kind of typically what you'll do is your X value will be like the number of steps in your model during training time. And then your Y value will be something like your training loss or your accuracy or anything else you might want to plot on there. And then it also allows you to put a lot of other interesting things, for example, images, and you can see how they'll change over time. So as the model progresses and trains and gets better, you can see how it's learning or where it might be making mistakes or what you might have to fix. And it also allows you to put things like bounding boxes for object detection. This is obviously just garbled noise, just because they're just trying to show you what you can do with it. And it also has things for things like audio, so you can also see what the audio output would be as the model trains, and the different weight distributions of your model as it's training. So you can see how these are distributed for example, for different layers inside of the model. It also allows you to see your principal component analysis. So this is for your MNIST data set, which is pretty cool. I thought that was pretty nice. And lastly, things like text, if you're doing any sort of NLP, and your precision and recall curves. So that's just kind of to show you. I'll actually show you how you can implement that inside of a real example, which I'll do with the transfer learning example. So let's close this and then stop this. So I wrote a little simple script or documentation on here where I have a Jupyter notebook basically going through a really simple example of transfer learning using this 102 flowers data set, which is basically 102 different kinds of flowers, which you can look here. It's from the University of Oxford. And it's a relatively small data set. I think it's something like 9,000 images or 8,000 images. So it's a perfect candidate for transfer learning using PyTorch on here. And you guys can see this okay? Is that all right? Okay. So all these packages here that you're seeing on here, are installed in the VM already, so you don't have to worry about that. This is what I was telling you before, how you need to install Tensorboard X as well as TensorFlow to import this summary writer. So this summary writer is basically the function that will allow you to log everything onto Tensorboard. So let's keep moving forward, and I can just kind of show you. So for this data set, and I'll put this on a GitHub, so you guys, if you guys want to poke around in there and look at it and see kind of how it works, you can. So the way this data set came was basically a single directory with all of the images, and then a MATLAB matrix that held all of the different labels. And the labels went from 1 to, I think, 102 for the amount of categories that are on there. So what I had to do was basically make a custom data set, because this is not one of the ones you can pull directly from PyTorch. PyTorch generally includes different data sets that you can use. So they'll have like scifar and MNIST and bash and MNIST. But since you're going to want to use your own stuff, you're going to want to know how to do use this dataset class that they provide in the utils function over here. So I won't go too deep into kind of what's going on here. I'm just basically loading the matrix from that MATLAB matrix and returning that label and the image. So this will get each individual item at a time. One important thing that you kind of need to know is that they have to be 0 indexed. So the labels come 1 to 102, but you want them to be 0 to 101. That gave me a big headache for a while, because I didn't think about that. So yeah, that's really important. Make sure that your labels are 0 indexed. And also, a really nice thing about using the PyTorch's dataset class and data loader and all that is that they have data transforms. So if you want to do any sort of augmentation or cropping or anything like that, it handles all of that for you, which is really, really nice. You don't have to worry about implementing any of that yourself. And it will also take care of any sort of batching. So if you want to load different batches on there, it'll do it for you. So here, what I did was I resized it, I cropped it to 224, and then I normalized it to this mean and standard deviation. So the reason that I picked these specific values, it has to do with the fact that I'm transfer learning. So the models that PyTorch provides are all trained on the ImageNet dataset, and they use these very specific values. So if you want to use the same values for yours, or else you'll be kind of destroying the weights that have already been learned, which wouldn't be good, right? That would basically nullify the entire point of transfer learning. And they have some documentation. I think I linked it down here to kind of show what you need to do. Yeah, this is it here, and they'll explain further down here that you have to have at least a size of 224 and this mean and standard deviation when you're doing it. So that's pretty important to include that transform so that you can do that. The other thing is, it's nice that it takes care of splitting the data up for you using this data random split function. So basically what I did was I just made a single data set, and then I broke up the size of it into 95% into the train size, and then 5% to the test. It was just some numbers I picked. It's probably not the optimal split that you would want, but just as an example. And then this will basically split up that flower data set that I originally made into a train data set and a test data set. From there, I use these the data loader that they include from PyTorch, which will basically allow you to pull batches. This is basically a generator that will allow you to loop through your data really nicely for whenever you're doing your training loop. And then you can choose your batch size. So I just set some hyperparameters up further up for do that, and I'll let them be shuffled every time they're pulled. So the next portion is, because we normalize the data and we actually want to see what's going on, you need to unnormalize it. So the way that I kind of did it up there is I loaded it in as a pillow image. If you see up here, I used Pillow to basically load this image, but obviously PyTorch doesn't use that. They use tensors, which is why there's this to-tensor transform down here, which will convert your image into a tensor. So we need to convert it back if we actually want to see what's happening with these models and such whenever you're trying to visualize it. So I just made some small little functions here for you to be able to see the images afterwards. So I'll unnormalize it, and then I'll basically plot it using matplotlib so you can see the batch. So I'll just load in a single iteration of that data loader, or the train loader. and then using some utils that PyTorch gives you, I make a little grid of that batch, and then we can kind of see here the different flowers. I obviously don't know the name of these flowers, so all that really matters is that I know what the labels are. So these are the actual labels that are included in the data set, and I want to make sure that when I train my model, that the predicted labels and the actual labels will match up. You could probably make like a list with the names, but it's kind of domain knowledge. So for me, I just needed to make sure that the labels would actually match up. Here we are kind of getting into the transfer learning part. So usually when you do transfer learning, you want to make sure that the layers that you are training are not being overridden by when you do the training loop. So you want to freeze all the layers and make sure that there is no updating happening whatsoever. So you basically loop through all of the parameters inside of your model and change this requires grad function to false, and that will basically stop the training process from happening altogether. So whenever you pass a model in here and you want to just stop the feature extracting part, because usually the way PyTorch does it is they'll split up your model into a feature extractor and then a classifier portion. So you can just kind of chop off the classification part of the model and put your own, since obviously you will have different numbers of labels on there. So ImageNet has 1,000, and then this one has 102. So you'll want to freeze everything and then put in your own classifier. Further down, I basically just grabbed a whole bunch of different models to train, because they are all slightly different how you would change the classifier on there. There's a lot of good documentation on this on the PyTorch website, which they kind of show here, which they'll explain how to do it for all the different models. Since all of them are slightly different in the manner that you have to change them, but here's just the examples. The important part is that you change the number of classes, as I was saying. So basically, I'm replacing in each of these models the classification portion of the model, so that I can train it and it will actually be able to output correct labels. And then I just place all of these different models in a dictionary, so I can loop through them and train them further down. And yeah, so this is kind of the meat of the model. So here we'll have the training function and then the testing function. They're pretty similar, but here I'll be able to show you where the Tensorboard portion kind of comes in. So this is pretty like standard boilerplate, like PyTorch training. I probably won't go too much into that. There's a lot of really great tutorials on the PyTorch website and other places that you can look. And the important part is down here. So this is this add scalar and add figure. So this is what allows you to actually place whatever values you want into your Tensorboard graph and visualization, so you can see what is happening with your model. So add scalar is what allows you to kind of place things like your training loss or your test loss and your accuracy metrics or whatever other metrics you might want to put on there. And the important part first is that you keep track of your training step, right? Because what happens is normally you'll have like an epic and a training step, and then the training step will reset, then you'll have your epic continue. That will like mess everything up because it'll overwrite data. So you need a continuous like stream of numbers, so they continually go up. So you need to keep track of what your training step is, and I just wrote a simple counter there that will increase every loop on there. And the other portion, so the scalar is pretty easy. You just kind of place whatever item you want. So for example, here I'm just placing the loss of the network on here from over here when I calculated the loss. And this is a little bit more interesting, the add figure. So here, Tensorboard actually allows you to use matplotlib figures. So in this case, you can actually just show the images, but I prefer figures because, for example, when I'm doing my own work, which I do a lot of pose estimation stuff, I want to place a lot of key points and things like that, and being able to like graph them on there. So this is super useful to be able to put a matplotlib figure and having a lot of different images, so you can see what's kind of going on with the network when it's learning and training. So up here, I wrote this TB figure function, where basically I just did almost exactly the same thing that I had done up above to show that that grid for the batch to see what's going on. And then what I'll do is I'll place for the title, I will place both the labels and the predicted. So over here, you can see me placing what the labels are. I'll place them on the CPU, and they'll have to be in NumPy, so you have to convert everything into NumPy for this to work the way it should. And then same thing with the predicted. And you'll also have to place it on the CPU for it to be converted onto NumPy. But once I actually show you guys the Tensorboard, you'll be able to see basically what happened on there. And this is to be able to put kind of the weights and the weight distributions on there where I showed you before. So the histograms of the weights and how they learn and kind of the values they converge to over time. So you can see that on there. This is just in the documentation. If you look on the Tensorboard X site, they'll have some OK documentation that you can kind of go through, and they'll show more examples of different things that you can do with it. But this is like a pretty basic and useful thing you can do. One really important point is that this does take up some computational power. So if you're training, this can actually cause a bottleneck if you're updating too often, which is why I only have it set to 100 here to show up every 100 training steps. So if you just have it going like crazy, that will slow down your model training significantly. So you want to be a little bit conservative with that and not overdo it. So that's a pretty important point. I'll usually also like to have something in the Jupyter Notebook so I can actually see what's happening. So I'll just have a print statement with all of the different information that I might find relevant or interesting. But that's just to make sure that it's actually training and not stuck somewhere. And then the test one is basically the exact same thing. I write another figure and add another scalar. So here I'm just looking at the loss and the accuracy down here. One thing that you can see is with these backslashes, this will actually group them under labels. Because if not, they'll kind of separate onto themselves and have a whole bunch of different tabs, which you don't really want. You want to be able to group things that you want to look at easily. So I made this. This will allow you to group them just using that backslash. And yeah, so that is the testing and the training loop. And then further down here, one thing that I did differently is because I'm writing. Yeah, go ahead. That's so normally in PyTorch, yeah, so that's passing the data from the GPU to the CPU. So normally in PyTorch, you actually have to pass your tensors from either the CPU or the GPU. So that's why I have further up here a device, right? So this device will tell where you want to place the tensors. So in PyTorch, you have to tell like your model where the tensor will be. So that's when you pass it to CPU, the only way to get into NumPy format is passing it to the CPU, because when it's on the GPU, it won't let you. So that's why I did that. It's a little strange. I have no idea, I'll be honest. I have no clue, but it has to be on the CPU. And so yeah, and that's all on here if you look. Yeah, basically. And here you can see that at each loop I actually place it on the device, and I actually have to do the same thing with the model. So I'll have this device for the images and the labels. So then afterwards I have to kind of copy it back onto the CPU, so that's in NumPy rather than having a PyTorch tensor. Exactly. Well, yeah, it just depends on what you. Yeah, no. Exactly. It won't read it that way, so that's why it has to be in NumPy, which is nice because PyTorch has such a nice integration between NumPy and itself, so you can easily switch back and forth between them. Moving on, here I was talking about the writer. So because I have multiple models, generally I wouldn't actually have the writer here in this loop, but I want to separate them so I can see what's happening with each model. So I'll instantiate a new writer object basically every time, and this is basically where the event files will save. So I basically just chose the name of the model, which is here from that dictionary that I originally made. and like the time, so that I can separate them out easily if I want to run them multiple times, which you want to do. That's the point of Tensorboard. You know, mess with hyperparameters, change something slightly, and then run it again, and then you'll be able to compare to see what happened. What did your tuning change something, and you know, maybe did it increase accuracy? So it's important to be able to differentiate between them. And here I'm placing each model on the GPU, similar to what we were talking about before. I say which loss and optimizer we want to use, which is cross entropy loss for classification in this case, and I'm just using Atom, just something nice and easy there. And then I'm just training and testing, right? And the important part is that I'm returning the train and test step, so that I'll keep a running loop in that sense. And then they obviously get zeroed out again for the new model. That way it keeps track of what's happening. So you would be running all this, so you'll hit run and have your model run. And what you'll do is you'll go back and do what we did previously, which was have Tensorboard running at the same time so you can see what's going on. So in this case, this was inside of this GCP folder. And here you can see there's a little folder called runs. The reason that there is actually a folder called runs is because, again, I called it that over here. I have runs, and then inside of it we'll have the event file name. So if I actually go in here and you look, you can see that there's the different models that were trained, and then the date and time and such. So Tensorboard would just read that. That way I wouldn't actually have to train it here in real time, because obviously that would take forever. So from here, you just do, once again, Tensorboard logdir to point it towards your directory that holds all your event files, and then that was runs, and it'll start running. And generally, you would do this while your model is training, so you can see what's happening. But it'll obviously stay there for you to be able to check out afterwards. Yes, it'll update it. I think it's every 30 seconds, but you can update it yourself. There's a little button there that will show you. So let me show you real quick. That's 8080. So up here, you'll see that there's this little refresh, and that'll let you refresh what's happening. Let me make this a tiny bit smaller. Yeah. So here you can see all of since I just have the accuracy and the test. So that was what I was talking about, so how I had test, and I grouped them together with that backslash. So that'll let you have them easily, grouped, so that you can see exactly what's going on. And the other important point is, since these are the tests, I only logged them every, I think it was 10 steps. And because I had a batch size of 16, there wasn't actually that many test steps. But you can see how over time the accuracy improved, and you can also kind of compare how the different models did. So that's pretty useful. And then for your training data, it's the same idea, obviously. And here you obviously have more steps because I was logging it more often. And you can see the loss, decreasing for all of these different models, and how their accuracy increased over time with each iteration. Here is the kind of nice portion. You can individually select models, so you can see what happened with them. So you don't have to see all of the runs all at once, because that can be a little confusing. So if you go back, you'll see what happened with this one specific model, and then have another one at the same time, so you can compare two different models in that way. Like I was saying here, it's a little hard to see, just because it got so big. There's no easy way to adjust in between. But let me maybe try and. I don't know if you guys can read the labels, but you can see how I place the title for what the actual labels are and what the predictions are. And when you scroll through here, this will let you see how the model probably improved over time. So if you go all the way back, you'll see it's actually not going to be terrible, just because it was trained on ImageNet. So like baseline is just going to have a good amount of accuracy. But it obviously improves over time, as you guys saw with the accuracy metrics up there. So that's really nice to see. Classification it's probably not the best example to see this. Something like object detection or pose estimation or many other different computer vision applications, or NLP and for that matter, would let you see what is happening. And if we had maybe something that wasn't so complex, such as flowers, if you had something like cats and dogs, or like the CIFAR data set, you could see where it's getting it wrong and be like, oh, okay, maybe I should take a look at my data. Is it imbalanced? Is there some bad, images in there? And it kind of points you in the right direction, which is really nice. So Tensorboard can be super useful for being able to visualize and debug, and it allows you to put basically whatever you want on there. I think it also allows you to do videos, but you have to install a separate library to do that if you're doing any sort of like tracking or something. Yeah, that's basically the talk. If you guys have any questions, let me know. Yeah. Uh-huh. Right. 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 Mm-hmm. Yeah, so generally when I have something like that, I'll take a look at the data. That's the first thing that I'll see. Like, is my data set balanced? Do I have enough images of something to see if this will work? There are some weird cases like that where sometimes models will learn so well, but it's actually hard to tell because for some people, they don't even know, right? For the example you're saying, because that's one of those like psychological things where somebody will look at that and they'll think it's a duck, and another person will look at it and think it's a rabbit, right? That's kind of a very niche case that would be very difficult to solve, I think, in that situation, because technically it's both, depending on what you're looking at. So that would be kind of a hard situation there. But generally, you would be looking at more when there's like a blatant error, or to kind of take a look at your data and see if there's something wrong with your data. But a situation like that would be, I'll be honest, I'm not 100% sure how you would solve something like that. So, anybody else? Any other questions? Yeah, sure. Sorry about that. I forgot we had those other ones. Yeah, since it's kind of huge model, you'll see there's a ton of different features that you can see, and for some reason this one didn't actually log them on there. There's probably a bug somewhere, but. Yeah, exactly. So if you look over in the histograms, you'll see here where it kind of converged to. Yeah, and the other really nice thing that this will allow you to do is if you have a model, it'll actually let you see the graph itself, because PyTorch, from what I remember, doesn't have an easy way to see what the graph looks like the full model. So you can place that in there to see what is actually like the flow of everything that's happening in there. You just have to like feed it some dummy data. So it'll just make like a random tensor the shape of your input and feed it through, and then it'll kind of trace it along, and then you can see what is going on in the model. That's another portion on there. I didn't actually place it on here because when you have multiple models like this, it'll kind of get screwy. Because it'll try to like overwrite one on top of the other, and it gets kind of messy. So if you had like a single model, then you could see that in that manner. Yeah.
So in your scalars, there are statistics. I assume they're multiplying in the same graph, right?
What was that? I'm sorry?
So in your scalars, there are multiplying in the same graph.
Yes. So that is the same like values for each of the for each of the models. So that this is just showing so you can compare like how is the test or the train accuracy of ResNet 50 versus AlexNet, right? So it's the exact same thing. That's why they're on top of each other. So you can just more easily compare and see what's kind of going on with your model, and you can zoom in and do all kinds of stuff on here for you to kind of mess with it. So yeah, cool. Any other questions? Yes. Okay. I can't really hear you. Could you speak up a little bit? Sorry about that. Right. So if you have something that's like way larger or way smaller, so generally for those cases, you would just have to resize it to this. So if it's much larger, it's okay. So that was one of the points I was showing, that it has to be at least of size 224. When it's too small, so like for example, I think the MNIST data set is something like 64 by 64. There, you would just basically have to resize it to be a 224 by 224 image if you're going to try and do transfer learning in that case. For it to work correctly, because any images smaller than that won't work. But if you have images that are too large, even though generally you don't want images that are massive, because that'll slow down the network a lot, like the training significantly. So I don't remember exactly why they picked 224, but that's like a very standard size that you pick. So you want to be you want to choose something that's pretty similar to that. Is similar to the output that you would normally get, right? So in that case, if you have an image that is too large for this model, I've heard of some techniques where they'll do is they'll kind of like break it up into smaller sections and then kind of merge them back together. I don't actually know too much about that, if I'm honest with you, but that is something that I've heard, especially for like object detection. When you have like a really, really small object, they'll like try and detect in regions inside of the image, and they'll kind of do like a histogram of gradients approach, a sliding window approach, sorry, where they'll kind of go through it like that. But yeah, if you have something that is way too large, you're just going to have to want to scale it down, because then it'll slow down your network significantly. Yeah. Anybody else? Yeah. Uh-huh. Mm-hmm. Yes, yes. If you go, I'm pretty sure there is that they have Inception. I think the weird thing with Inception is, yeah, here they go. They have Inception v3. Let me try and make this a little bit larger. So these are the different networks that they actually provide for you, and they give you the top arrow. So if you look down here, they have Inception v3 over here, and like DenseNet and the different like sizes of them. So yeah, but these are all the models. They don't have everything, obviously, and I think TensorFlow 2.0 just came out, which they added a whole bunch of different stuff on there and a whole bunch of other models. So yeah, but they have it can be really useful for a lot of different tasks, depending on what you want to do. Did that answer your question? Did that answer your question? Okay. Gotcha. It's yeah, the thing with Inception is that it has two outputs rather than the normal, where normally, like if you're doing something like ResNet, it'll just have one vector of whatever size classes that you have. Inception has two. I'll be honest, I've never used Inception. I don't actually know why they do that. So yeah, I'm not totally sure. Oh, TF records. I don't have too much experience with TF records, so with PyTorch, it's just using like that data loader framework. So that data framework, you use a custom data set class that they have and implement it for whatever data you're trying to load. So it's similar in that it does the augmentation like on the fly as it's happening. When it's being loaded, that's when all of those transforms are being applied. But I'll be honest, I don't know too much about TF records. I've been mainly using PyTorch. Yeah. Anybody else? Any other questions? No? Well, oh yes, go ahead, sorry. Right. No, you could. You don't have to. So just the way that I set it up here, it's like a uniform because I just have one like training loop for that. I mean, you can still load in like pre-trained models that you've previously trained and like continue training on there, or have a different set of scalars. But just because I've made this like uniform little training loop, it'll have the same. But it doesn't have to be that way. It's pretty flexible, but it can also be messy. If you do it incorrectly, it'll kind of like I was telling you, like overwrite data, and you have to be a little bit careful with that. But it's not. It's pretty flexible in that sense. Yes, event files. So the objects themselves don't. I don't think. I don't think you can save those. So like the summary, I think you're talking about like this summarizer object here. Continue, right? To be the same as previously. I have a feeling there is a way to do that. It's probably on the documentation, but yeah. Okay, cool. Anybody else? Yes. What was that? I'm sorry. Monitor settings. Saliency. More than. Yeah. More than likely, I don't actually know, if I'm completely honest with you. I know that's like an NLB task, and I almost never like have any experience in that area. I'm mainly computer vision, but is saliency some sort of scalar value, or what exactly is saliency? Is that just like would that be like a heat map of where it's paying attention? It's basically a heat map. So you can like output a heat map, right? So that's similar to what I do when I'm doing pose estimation. I'll just basically have like a mask on top of the image that will like spit out instead of spitting out a single like 1,000. Well, it'll be a 1,000 like images or whatever the size of the vector that I want, and then I'll just reshape it and like plot it as a figure. That way you can see where it's paying attention. Exactly. So it would be basically like an image. So you basically would use something like matplotlib and basically reshape the tensor that outputs from your network into whatever it is that you're trying to have, like wherever it's paying attention. So if you had like you wanted to see where the network is paying attention to whenever it's trying to make a detection or something like that, you would just take that tensor, reshape it, change it into a pillow image, and then plot it on matplotlib using a figure. So you have to do a little bit of work. It's not super plug and play in that sense. But it would still allow you to do something like that. So that's a nice thing. It's pretty flexible, and which is why I use the matplotlib figure thing rather than just like an image show. So yeah, you could probably do something like that, and that's similar to what I do like at work whenever I'm doing things like that. Yeah. Anybody else? No? Yeah. Thank you guys. I really appreciate it coming out and listening to me. Oh, and one quick thing. We are actually looking for another computer vision engineer to come work with us at Immersed for 3D pose estimation. So if you guys want to work on really cool, like bleeding edge machine learning stuff, not a lot of companies have 3D pose estimation working in their products. So if you're interested, we're hiring. Cool. Thank you.
Thank you so much, Pablo. That was fantastic. That concludes the meetup tonight. Reminder that we're going to move over to CU29 right across the street. Look forward to seeing you there and continue this conversation. All right, see you there.